Welcome to the Apollo Learning Crash Course. In this 2-hour-long video, we're going to cover the 3 primary skills that you need to master in order to kick the ACT's ass. Timing, strategy, and content. And for the content section, we're actually going to head to the blackboard and work out the 10 most common concepts that you'll find on the ACT. This is a fairly long video, but remember that it's a crash course, meaning it's condensed as we could possibly make it. So everything covered in this video will likely be on the next ACT that you take. So you're going to want to pay really close attention because you do not want to miss anything. The former 2-division world champion Conor McGregor once said, "Precision beats power and timing beats speed." So what does that mean, timing beats speed? So speed is an attribute. It's typically something that you're born with or you're born without. And it represents how quickly you're able to do something. Whereas timing is a skill that you develop over time. And it's whenever you know when to do something and when not to do something. And for the sake of this video, we're going to focus almost exclusively on timing because timing really does beat speed on the ACT. I've known some students that were very fast at math, that were very, very bad at getting answers correct. And I've had students that were very, very slow at math, that were very, very accurate in their answers. So we're going to focus exclusively on timing. But before we can talk about timing, what are we timing? So we're looking at the ACT mathematics portion, which is a 60-question multiple choice test that covers geometry, trigonometry, algebra, and a little bit of statistics. We're allowed to use a calculator, and in my opinion, they're pretty much mandatory because if you don't use a calculator, you will regret it. And then lastly, and this might be the most important for the sake of this video, the questions vary greatly in difficulty and increase in average difficulty. So what this means is typically the easiest questions are first and the hardest questions are last. But there's giant variability between questions, which means you could have a really easy question right next to a very, very difficult question. All right, so we have 60 minutes to answer 60 questions. That gives us about a minute per question. But you're not going to want to spend a minute on each question. You're going to want to break it up as perfectly as you can. And that's what we're going to talk about here. So imagine instead of a 60-question test, if you had a 5-question test. All right, and you're going to take this test with no time constraint. You're just going to do it as quickly as you could possibly do it while still being accurate. So you take on the first question. You get it correct and it takes a minute. The second question, you get it incorrect, it takes 3 minutes. The third question, you get it correct, it takes 2 minutes. The fourth question, you get it correct, it takes 30 seconds. And then the last question, you get it correct, but it takes 1 minute and 30 seconds. All right, so that took you about 8 minutes to get 4 questions correct. But as on the ACT, how we only have 1 minute per question, now let's put that time restraint on this particular test. So you do question 1. Question 1 is going to take you 1 minute. So you have 4 minutes left, and now you have 1 question correct. Then you go to question 2. Question 2 takes you 3 minutes, and you get it incorrect. So now you've spent 4 minutes, and you only have 1 problem correct. So now you go on to question number 5, which you would get correct, but it takes 2 full minutes to do. So you run out of time whenever you're halfway done with question 3. So if you do it in numerical order, you end up getting 1 question correct in 5 minutes. So now let's look at it if instead of doing that, we skip the second one. So we're going to skip the one that looks difficult. Because typically whenever you look at a math problem, you know whether or not you know how to do it. And you know how long it'll take you. So say we skip around. Instead of going straight through in order, we skip the ones that look difficult. And number 2 and number 3 look difficult. All right, so we do question number 1. It looks easy, we take care of it in 1 minute, we finish it. So now we have 1 question correct and we have 4 minutes remaining. So we see question number 2, we skip it. We see question number 3, we skip it. We go on to question number 4. It takes us 30 seconds and we get it correct. So now we have 2 answers correct and only 3 minutes and 30 seconds remaining. All right, so now you go into the last question. It looks pretty easy, so you take it on. And you successfully get it correct, and it takes you 1.5 minutes. So you have 2 full minutes remaining, and you have 3 questions correct. So now you have to choose between doing question number 2 or question number 3. You think question number 3 looks easier, so you do question number 3. It takes you 2 minutes, and you finish right on time. So what ends up happening is you got 4 questions correct in 5 minutes. So the first method, where you just went in order, you end up getting 1 out of 5 correct. But in the second method, where you skipped around and you chose to do the ones that looked the easiest, you ended up getting 4 out of 5 correct. That is a dramatic difference. And that's without improving your mathematical skill, ability, or speed whatsoever. All you did was take the test in a different order. and you did that by just skipping questions. And I say just skipping questions, but it's not as simple as just skipping questions. Skipping questions properly on the ACT is an art form. And now we're going to go over tips to help you master the art of the skip. One of the biggest hurdles that students face in mastering their ACT timing is the force of habit. So typically you're taught to take a test in a linear format, right? So you start at question 1 and you work your way to the end. But on the ACT, this is not how you should do it. And the reason why is because it's a timed test. And it's timed in a way where they know that a majority of students will run out of time before they're able to give full effort on every question. So you're going to have to use your time wisely. And the way we do that best, and the way I get students to get rid of that mental block, is you're going to take the test 2 times. You're going to take 2 separate tests whenever you take that ACT. The first test, you're going to go through and you're going to select all the questions that you want to do, that it looks like you can do, and looks like you could do in a quick fashion. You're going to do those, and you're going to skip the ones that look difficult and put a box around them. Now for the second test, you're going to come back to the ones that are more difficult, and you're going to sludge through those and try to get as many of them right as you possibly can. So, by taking the test twice, you're going to be going in with the mindset, okay, there's going to be a ton of questions that I'm going to skip. And you're going to skip all the ones that look time-consuming, like they'll just drain your time. And that'll make sure that you get to all of the questions that are within your wheelhouse. So that's the first tip. Take the test twice. The second tip is always trust your gut. So whenever you look at a question, you typically can tell whether or not you have the mathematical knowledge to solve it or not. And you typically get an instant idea of what the first step is. But if you don't get the idea of the first step, immediately pass on it. There's no point in pontificating about it. You don't want to think about it. You don't want to spend 30 seconds deciding whether to pass it or not, because you could come back to it anyway. It takes about a half a second to choose to skip a problem. You should be skipping it almost instantaneously. Half a second, 1 second, 2 seconds max. So use your gut. Tip number 3, know when to give up. So a lot of students, once they start investing time in a problem, they feel obligated to finish it. Because if you spend a minute on a problem and then get to a roadblock, you feel like if you skip that question, you just completely wasted that 1 minute. And yeah, that might be true, but it's better to waste 1 minute than to waste 3. If you're at a total roadblock and you have no clue where to go and you've already spent a minute and a half on the problem, there's a very small likelihood that you're going to figure it out in the next 5 to 10 seconds. So you're better off just moving on and going to problems that you actually can do, and then coming back to that question on your second go round through the test. And lastly, make sure you double check your Scantron. Every single time that you skip a question, make sure that you skip in your Scantron, because there's no worse feeling than getting to the end of the test, filling in your last bubble, and realizing that you just filled in the bubble for answer choice 59, meaning that your whole Scantron is wrong. Because if you put your answers out of order, they will be all counted wrong unless you just randomly got some correct. So make sure you double check your Scantron every single time you skip. All right, now that we've talked about timing strategy, let's talk about implementation. So you never want to first try to implement a new strategy on an actual ACT. You want to do it in practice first. Same thing with any sport. You would never want to try out a new play or a new move in an actual competition. You want to do it in practice first so that you can give it some repetition, perfect it, and then bring it to competition. And the reason why is because if you don't do that and you do it sloppily, it's likely to end up being counterproductive. All right, so the major key for all of the strategies that you'll learn today is to practice, practice, practice. And don't just practice in a bland way. You need to practice in a very precise way. So I'm going to give you 4 tips to help you in your practice. Tip number 1, make sure that you always time yourself. And don't just time yourself, but use a stopwatch. And the reason why is because even if you run out of time, you want to continue to take that test and see how long it would have took you to finish the whole test. So that you can track to see how much closer you're getting to your goal of finishing 60 questions in 60 minutes. Tip number 2, record your time at 10 question intervals. So record your time at question 10, 20, 30, and onward. You want as much data as possible to inform your timing strategy. And also, if you're doing the 2-test strategy, time test 1 and time test 2. More data is always a good thing. All right, tip number 3, don't zoom through the easy questions. So a lot of students have a problem of going too quickly through the easy questions where they end up making simple mistakes. And don't get me wrong, you should go a little bit faster through the easy questions than you would the hard questions, obviously. But you don't want to go so fast that you end up missing easy questions. So never zoom through the easy questions. And then lastly, and this one is very important, take the extra time to write neat. For each question, it might take you an extra 1 or 2 seconds just to write a little bit neater than you would naturally. This ends up saving you time because whenever you go back to a question or you're double checking a question, you have everything written out all pretty in perfect notation. So take the little bit of extra time to write neat. And don't go overboard with this. You don't need to write perfectly, but just write a little bit neat. Take an extra 1 or 2 seconds to just be smooth in your writing, make your positive and negative signs visible, and just make sure your notation is up to par. Good timing is essential for a good ACT score, but it's not sufficient to get you there. So the ACT doesn't grade you on your timing, it grades you on which answers you fill in correctly. So in this section, we're going to talk entirely about strategies, tips, and tricks to get you to that correct answer. Alright, so the first strategy that we're going to talk about is process of elimination, and it's probably one that you've used many times in your everyday life. So say you were given the option between 3 movies, romance, horror, and action. If you really didn't like horror movies, the first thing that you would do when making that decision would probably be, not horror movies, we're not going to do a horror movie. So then it would just be between action and romance. So you eliminated a possible choice in order to narrow down your decision-making process. And that's exactly what we're going to do in the ACT. So the first version of process of elimination is eliminating absurd answers. Alright, so in order to see what that really means, we're going to look at an officially released ACT practice test. Alright, so on this practice test, question number 30 says, Maria ordered a pizza. She ate only 2/9 of it and gave the remaining to her 3 brothers. What fraction of the whole pizza will each of Maria's brothers receive if they share the pizza equally? Alright, so we know that she ate 2/9 and then they split up the remaining pizza between 3 brothers. So even if you don't know how to do this, answer choice F is saying that each brother ate 7/9 of the pizza, which would mean that each brother ate a vast majority of the pizza, but you can't have 3 different people eat a majority of something. That wouldn't make sense. So we know that answer choice F is going to be out. Answer choice G, they ate 3/7 of the pizza. So that doesn't make sense either because that would mean that 3/7, 3/7, 3/7, that means the brothers total ate 9/7 of a pizza. So that would not make any sense whatsoever because that would be more than a whole pizza. And we know that we were already starting out with Maria eating 2/9 of the pizza. So we were starting out with less than a whole pizza. And answer choice G is ending with more than a whole pizza. So that's out. Answer choice H, each brother ate 1/3 of the pizza. So if each brother ate 1/3 of the pizza, that would mean that together they ate a whole pizza. But we know that that can't be true because Maria ate some of the pizza. So answer choice H would also be out. If you look at answer choice J and K, there's nothing that we can immediately do like that to immediately eliminate them. So we'll just leave it between them. But think about it. If we eliminate 3 options, that means that we have a 50-50 chance of guessing the correct answer, even if we don't know how to do it, because there's only 2 options left. And if you could do that for every question, if you could eliminate 1, 2, even 3 questions, you drastically improve your chance of guessing correctly or even answering the question correctly. It narrows down your decision-making process. Alright, on to the next one. So Jorge's current hourly wage for working at Denty Smiles is $12 an hour. He was told at the beginning of next month his new hourly wage will increase by 6% of his current hourly wage. What will Jorge's new hourly wage be? Alright, so if we look at F, G, and H, they're all in the 12 range. But then J and K are 18 and 19. So it's saying 6% of $12. So 18 is more like 50% of $12. So we know that that's way out of the range. So we can eliminate that right off the bat. Eliminate J. And then K is even higher than J. So bam, that's an absurd answer as well. We can eliminate that. So now we're choosing between 3 answers, which is much easier than choosing between 5 answers. So that is the strategy of using process of elimination to eliminate absurd answers. Alright, now for the next one. Figures are drawn to scale. On the ACT, it always says figures are not drawn to scale, but for all practical purposes, the figures actually are drawn to scale. So if you look at every single practice question ever released by the ACT, all of them are pretty much drawn to scale. I'm sure if you measured it at a very, very tiny level, it wouldn't be to scale. But just eyeballing it, it will be to scale. So let's look at how we can use that to eliminate some answers. In the circle shown below, chords TR and QS intersect at P, which is the center of the circle. And the measure of PST is 30 degrees. What is the measure of minor arc RS? Say you had no clue how to do this whatsoever, but you just wanted to eliminate some answers to make it more likely that you get the question correct. We can use this figure. And the way I like to do this is if you take the tip of your paper and you bend it over, you can actually draw a perfect 90-degree angle on your paper wherever you need to. Right? So if we line it up perfectly with line PS, we can draw a line perpendicular to line PS, which makes a 90-degree angle. So now that we have that, we see that there's two angles made within this 90-degree angle. One of them is obviously larger than 45 degrees, and one of them is obviously smaller than 45 degrees. So we have both of those. And since we're looking for SPR, angle SPR, or arc length RS, we know that we can eliminate all options that are less than 45 degrees. So let's look. F is out, G is out. So now we're between H, J, and K. But it's very, very obvious that J is not the correct answer either because angle SPR is obviously not 90 degrees. So that's out as well. So now we're just between H and K. So we were able to eliminate all the way down only to two answers where we have a 50-50 chance of getting it correct without doing any math or really knowing how to do anything in this problem. All right, so on to the next problem. This one's very similar as well. So we're going to make our 90-degree angle again using our straight edge. So fold it over, make the 90-degree angle. And now the question reads, in the figure below, B lies on AC, BD bisects ABE, and BE bisects CBD. What is the measure of DBE? So we're looking for this angle right here, DBE. And we know that it's greater than 45 degrees. So looking at this, it is obvious that EBD is greater than 45 and that DB to the line that we created is going to be less than 45. So since we're looking for DBE, we can eliminate all angles that are going to be less than 45. So let's do that. C is out, D is out, A is obviously out because it's obviously not a 90-degree angle if it doesn't match up perfectly with the angle that we drew. So now again, it's between 60 and cannot be determined from the given information. So again, we have a very similar problem that we were able to completely handle without knowing how to do any of it, using the figures against themselves and process of elimination. And now for my personal favorite, we're going to go over plug and chug. So as the name suggests, in plug and chug, you're going to take numbers from a source and you're going to plug them into the question and see what you get. So the first type of plug and chug we're going to talk about is using the answer choices themselves. All right, so let's look at some questions. What values of x are solutions for x squared plus 2x equals 8? All right, so if you had no clue how to do this, I hope you know how to do this, but if you don't, you would take numbers from the answer choices and you would just plug them in. So like for this, let's start with A. So let's plug in -4 for x. So we have -4 squared plus 2 times -4 equals 8. Let's see if that pans out. So -4 squared is going to give us 16. 2 times -4 is going to give us -8. And then 16 plus -8 will end up giving us 8. So we know that 8 will be a solution. And we found that by back solving or plugging and chugging. And if you look at all the other answer choices, there's no other answer choice that has a -4 as an answer. Therefore, we know that it's going to have to be answer choice A. All right, for the second question, what is the least common multiple of 70, 60, and 50? All right, so a multiple is a number that can be divided evenly by another number with no remainder. And we're looking for the least common multiple. Because of that, we're going to want to start at the lowest number, because if you start at the highest number, that might end up being a multiple, but it might not be the least multiple. All right, so let's start at 60 and work our way up. And we can just plug this into the calculator. So 60 divided by 70, that would give us a remainder. 180 divided by 70, that would give us a remainder. 210 divided by 70, that would be no remainder. But then 210 divided by 60, that would give us a remainder. But then J, so 2,100 divided by 70, we get no remainder. Divided by 60, we get no remainder. And then divided by 50, we also get no remainder. And the same is true for K, but since we're looking for the least one, it's going to be answer choice J. All right, now for the last question. And this one's a little bit different. So in the other questions, we took numbers from the answer and we plugged them into the question. But for this one, we're actually taking numbers from the question and plugging them into the answer. And the reason why is because this one is asking for the equation that represents D and T. All right, so let's look at it. We're going to take a T value and we're going to plug it into the equation and see if the D value is the D value given in our function. All right, so let's do T equals 2. So when T is equal to 2, D should be equal to 26. So let's plug that into all these equations and see what we get. So for answer choice A, when D is 2, you get 2 plus 14 is equal to 16. So D would be equal to 16. That's not correct. Answer choice B, so T would be 2, so it'd be 2 times 6 is 12, plus 8 would give us 20. 20 is not 26, so answer choice B is out. Answer choice C, so 6 times 2 is 12, plus 14 would give us 26. Okay, that's a possible answer, but let's look at the rest of them. So 14 times 2 is going to end up giving us 28, plus 6, that is not 26, so answer choice D is out. And then lastly, answer choice E is going to be 34 times 2, which is not 26, so answer choice E is out. So answer choice C will be the correct answer. But for questions like this, a lot of times you'll choose a number and there'll be two answers that still have correct values. And what you do at that point is you just choose a different T value and run it again with just those two equations. So that's how you got to answer choice C using plug and chug. All right. But now for our next type of plug and chug, instead of plugging in answer choices, you're going to plug in strategic numbers. And by strategic numbers, sometimes it really just means random numbers. But you have to kind of be strategic with it. You don't want to plug in 1,000 or 1,000,000 or anything like that. You want to keep it low and simple. All right, so let's look at the first problem like this. If A, B, and C are positive integers such that A to the B power equals X and C to the B power equals Y, then X to the Y power equals what? All right, so for this, it tells us A, B, and C are positive integers. So all we have to do right here is we can actually just plug in random positive integers for A, B, and C, and as long as we keep them consistent, we'll be able to get the correct answer. And I'll show you how. So let's make A equal to 2, B equal to 3, and C equal to 4. And then let's just solve. So we know that A to the B power is equal to X, which would be the equivalent using our little scheme that we just devised. So A is going to be equal to 2, B is going to be equal to 3, so this would be the equivalent of 2 to the third power is equal to X. So that would end up giving us 8 is equal to X. All right, so now let's find Y. So we know C to the B power is equal to Y, and we know our C is 4 and our B is 3. So we do 4 to the third power is equal to Y, which would end up giving us 64 is equal to Y. So now we have X is equal to 8 and Y is equal to 64. And they're asking us what is X times Y. So we're going to do X times Y, so 8 times 64, and that's going to give us 512. So now all we have to do is go back to all the answer choices and plug in our values of A, B, and C, and see which one lines up with the answer that we just got, 512. All right. So A times C to the B would be 2 times 4 to the third, which would give 128. So that can't be the correct answer. Answer choice G, so A times C to the 2B power, so that'd be 2 times 4 to the 6th, which would be way over. So that'd be like 8,000, something like that. All right, now answer choice H, it would end up being 2 times 4 to the third power, which would be 8 to the third power, or 512, which would be the same answer that we got. So that'll be the correct answer right there. So answer choice H will be the correct answer. So I hope you see how we plugged in strategic values for all those numbers and it helped us get to the correct answer using plug and chug. All right, now for the last question. Which of the following expressions is equivalent to X to the 2/3 power? All right, so for this we can plug in a random number for X, and as long as we keep that number consistent and plug that value for X into all of the answer choices, whenever we find out which of the answer choices is equivalent to the one that we did in the beginning, we know that that will be the correct answer. All right, so let's do that. Let's make X equal to 2 because it's a simple, even, positive number. So we do 2 to the 2/3 power, and we put that in the calculator, and that would give us 1.59. All right, so now all we have to do is go into each answer choice and plug in 2 for X. So for answer choice F, if we did 2 squared divided by 3, we'd get 1.33. So that's not equivalent, so F is out. So for G, we do 2 times 2 divided by 3, which would again give us 1.33, so that's out. For H, if we did 2 to the third power and then we took the square root of that, that would end up giving us 2.82, which is not equivalent either. For answer choice J, if we did 2 to the cube root, that would give us 1.25, so that's not it either. And then lastly, for K, if we plug in 2 there and we throw it in our calculator, we end up getting 1.59, which is equivalent to 2 to the 2/3 power. So that'll end up being the correct answer, answer choice K. Alright, before we get into the calculator functions, I want to give you all a brief warning. So do not overuse these. Some students will overuse calculator tricks and functions, and it ends up wasting them time. So try to do it the right way, and then if you fail at that, or you can't do it, or you think it'd be more efficient to do it with a calculator, then do it with a calculator. But don't over-rely on your calculator. Alright, so we're only doing a few calculator functions on here because I chose the ones that were the most streamlined and efficient. Alright, so the first one that we're going to do is one that I really like and is super efficient. It's the frac and dec functions. Alright, so say we have a decimal number, 1.504997061, and we wanted to convert it to a fraction. That would likely be very difficult for you to convert into a fraction by hand. But, lucky for you, we have a function on the calculator that does this instantaneously. So all you have to do is you press the math button, then you scroll to frac, which is typically the first one, and you press enter, and then enter one more time, and bam, it is converted into its simplified fraction. Now say you wanted to convert it back to a decimal. All you have to do is press math again, but scroll down to dec, and whenever you hit enter, enter again, it converts it into decimal form. And the reason why this is so handy is because if you ever need to reduce a fraction, all you have to do is first convert it to a decimal using dec, and then convert it back to a fraction using frac, and it'll be in its most simplified form, just like that. Alright, for the second calculator trick, I'm going to show you how to work with imaginary numbers using your calculator. Alright, so say you have the question, what is the product of the complex numbers -3i plus 4 and 3i plus 4? Literally, all you have to do is just plug it in your calculator, but you have to know how to put an I into your calculator. Alright, so if you look above the decimal button, there's a little bitty blue I. So in order to activate that blue I, you just have to press the blue second button at the top left-hand corner of the calculator, and then press the decimal button, and it will give you an I. So let's just type in that problem exactly as is. So we're going to do parentheses -3i plus 4 times parentheses 3i plus 4. We press enter, and it's going to give us the answer, which is 25. Alright, very simple. And if you ever forget what I equals or I squared equals or I cubed equals, you can just throw it into the calculator. So it'll show you I squared is equal to -1, I cubed is equal to -I, and I to the 4th power is equal to 1. So that will serve as a good reminder if you ever forget your I rules. Alright, now for working with scientific notation. Say you had this question. In scientific notation, 670 million plus 700 million is equal to what? You just plug it into your calculator as is, get your answer, and then you press mode, you go down one, and you change the mode of the calculator from normal to sci, which stands for scientific. And then you press enter and enter again, and it will convert your answer into scientific notation automatically. So the E right there means times 10, and the number after the E will be the exponent that the 10 is to. So this means 1.37 times 10 to the 9th power, and that would be your answer for this question. But just make sure you turn it back to normal mode, or it will stay in scientific notation. In this Blackboard lesson, we're going to go over f of x and g of x, but we're going to do so in a non-graphical way. And what I mean by that is we're just going to look at the equations themselves and the results of switching variables or putting f of x inside of g of x, stuff like that. So if you look at f of x, anytime you change x, so instead of making it f of x, we make it f of 2. All you have to do is go into the equation itself and replace those x's with 2's, or the same number that you've been given. So it's pretty simple. It's just plugging in, right? And then we're going to look at f of g of x. So whenever you have an f of g of x, you just find the inside one. So if g of x is inside, you're just going to find g of whatever number you've been given. And then you're going to use that number as the x for f of x. So let's do some problems like that. If f of x is equal to 12x plus 3x squared, then f of 11 is what? All right, so we replace the x with an 11. So all we're going to do is go in this equation and replace these x's with 11s, right? So let's rewrite it. So f of 11 is going to be equal to 12 times 11 plus 3 times 11 squared. All right, so we're going to square 11, which is going to give us 121, and we're going to multiply that times 3. So 121 times 3 will give us 363. And then on this side, we're just going to do 12 times 11, so 12 times 11, and that will give us 132. And we're just going to add those together. So that plus 363 is going to give us 495. So we know that f of 11 is going to be equal to 495. All right, let's say we did this exact same equation, except we replaced 11 with 2. Right, so it's no longer 11, it's 2. We'd just go in here and replace all these x's with 2's again. So it would be 12 times 2 plus 3 times 2 squared. Make sure you only square the 2. If they wanted you to square the 3 and the x, there would be parentheses around the 3x and the 2 would be on the outside. The square symbol would be on the outside. All right, so 3 times 2 squared, so 3 times 4, that's going to give us 12, plus 12 times 2, which is going to give us 24. So that would be f of 2 is going to be equal to 36. If f of x is equal to x squared and g of x is equal to 25x minus 3x squared, then what is f of g of x if x is equal to 4? So remember your order of operations, PEMDAS. So you always do what's inside of the parentheses first. And since g of x is inside the f's parentheses, we're going to do it first, right? So let's solve g of x when x is equal to 4. So we're going to insert 4 into the equation. So this is now going to be 25 times 4, which is going to give us 100, minus 3 times 4 squared. So 4 squared is 16 times 3. That's going to give us 48. So we have g of 4 is equal to 100 minus 48, or 52. So now that we have that, now that we know it's 52, we could just come in this original equation and replace the g of x with 52. So let's do that. So it's no longer g of x, it is now 52. So now we're just going to go inside f of x, because this is just f of 52 now. So we're going to replace this x with a 52, and therefore replace this x with a 52. So now f of 52 is going to be equal to 52 squared. And 52 squared is going to be 2,704. So f of 52 is 2,704. So now we know that when g is 4 and we're looking for f of g of x, it's going to equal this. So we'd put f of g of x is equal to 2,704 when x is equal to 4. If f of x is equal to x squared plus 2 and g of x is equal to x plus 4, for what values of x does f of x equal g of x? All right, so since f of x is equivalent to this, we're just going to replace that. We're going to put that right here. And then since g of x is equal to this, we're going to replace it as well and put that right there. So now it's going to look like x squared plus 2 is equal to x plus 4. All right, so now that we got that, we're just going to move it all to one side and solve for x to where it's going to equal 0. All right, so let's do that. Subtract both sides by x to get rid of it. So subtract both sides by x. So now we have x squared plus 2 minus x is equal to 4. Let's get rid of that 4. So subtract both sides by 4. And we now have x squared minus x minus 2 is equal to 0, because nothing remains on this side right there. All right, so now we're just going to have to solve for this, and we're going to do this by turning this trinomial into two binomials, right? We're going to reverse FOIL it, or we're going to reverse factor it. Okay, so we know it's going to be two parentheses, and we have an x in the front, right? Because x times x is going to give us x squared. Now we need to find a number, two numbers, that multiply to get negative 2, but then add to get negative 1. And that would be true for negative 2 and positive 1, right? So let's check this. Let's FOIL it. Let's distribute it. So we're going to do x times x, and then we're going to do x times 1, and then negative 2 times x, and then negative 2 times 1. So x times x is x squared. X times 1 is going to give us positive 1x. Negative 2 times x is going to give us negative 2x. And then negative 2 times 1 is going to give us negative 2. And if we simplify this, we combine like terms, we're going to end up getting x squared minus x minus 2. All that equal to 0 still. All right, so we know that this is going to be correct because we were able to undo it and we still got the exact same thing as before. All right, so let's write this out. We have x minus 2 times x plus 1, all that equal to 0. So for what values of x is this true? Right, so we have to make either one of these sides 0 in order for the whole equation to be equal to 0. So when this x is positive 2, it'll be 2 minus 2, which would be 0, which would make the whole equation 0. And then when this x is negative 1, it would be negative 1 plus positive 1, which would be 0. So for these two values, the equation will equal 0. And that means that f of x is equal to g of x for positive 2 and negative 1. In this Blackboard lesson, we're going to go over functions. So what is a function? A function is something that you can plug data into, it'll chew it up, and it'll spit out new data. So for the ACT, you don't necessarily have to know what a function is, but you have to know really well what a function does and how to work with them. So in order to do so, we're going to look at these three functions right here and how they relate to this xy coordinate plane. All right, so let's look at f of x, our first function. So f of x is equal to x squared. So what does this function allow us to do? All right, so what it lets us do is choose any x value. We choose any x value and we plug it into this equation and it'll give us the y value for that particular equation. Okay, so if x is 1, we just plug the 1 in, so it'll be 1 squared. We know that y is going to be equal to 1 squared or 1. So when we have x of 1, we're going to have a y of 1, so our dot's going to be right there. What about for x is 3? So we just plug the 3 in. F of 3 is going to equal 3 squared, which will give us 9. And we just plug that in. So when x is 3, we have a y value of 9, which is up here. So what about for 0? So when x is 0 at this point right here, what is y going to be? So f of 0 would equal 0 squared, which would just equal 0. So our dot would be right here. Now let's go to a negative number. What about when x is negative 2? So right here. We just plug it in. It'll be negative 2 squared, and that's going to give us 4. So when x is negative 2, y is going to be 4. And if we drew this all out, we'd end up getting a parabola, right? So on the ACT, what the functions allow you to do is graph. They allow you to graph and they allow you to find values of equations at any given point. All right, so let's go to the next one, g of x. All right, so g of x is equal to 2x plus 1. So now that we have that, we can just throw in x values and find what our graph is going to look like. All right, so when x is equal to 1, we just plug it in. So 1 and 1. So it'll be 2 times 1, which is 2, plus 1 is 3. So when x is 1, y is 3. All right, now when x is 3, it's going to be 2 times 3. So 2 times 3 plus 1, which is going to give us 7. So when x is 3, y is going to be 7. And then lastly, let's do like 5, right? So when x is 5, it's going to equal 2 times 5 plus 1. And that's going to give us 11. So when x is 5, y is going to be 11. And if we did all of the different values, we'd end up getting a perfect straight line all the way going down like that. All right, so we have that one graphed. Let's do the next one. All right, so lastly we have h of x. So h of x is equal to negative x squared. All right, so we already graphed a function that was just x squared. So now every single value that we had of our parabola is just going to be reversed, right? So the negative in front of the x squared is just going to make every single value the opposite of what it was. So instead of having an upward facing parabola, we're going to have a downward facing parabola, a sad face parabola. All right, so now that we graphed all those, let's graph them together and see how they intersect. All right, so now we have our two functions drawn together. So one question could ask, at which points are g of x and f of x equivalent? So when is g of x equal to f of x? For which values of x? And the way we'd answer this is by simply looking at the graph and seeing where they intersect. So f of x and g of x are equivalent right there, and they're equivalent right there. In this Blackboard lesson, we're going to talk all about lines. All right, so let's start out with an equation for a line. All right, so we have our line, y equals 2x plus 1. All right, so let's look at the slope-intercept form. It's y equals mx plus b. So we know that 2 is going to be m, and 1 is going to be b, right? So m represents the slope. So we know the slope is going to be 2, and that b represents the y-intercept. So we know the y-intercept is going to be 1. All right, so what is a y-intercept? The y-intercept is the point at which the line crosses through the y-axis, and that'll be when x is equal to 0. Because when x is equal to 0, we're going to be on this y-axis. So we know the y-intercept is 1. So right there, the line is going to cross through the y-axis. And we know the slope is going to be 2. But how are we going to graph this line, right? The way we're going to do this is a function. So this formula is a function. If we plug in an x value, it'll give us the y value. So let's plug in a couple x values so we can graph this line. So if we make x equal to 1, it'll be 2 times 1 plus 1, which will give us 3. So it'll be 2 comma 3. All right, now let's do a negative number. Let's do negative 3. So if we put negative 3 in there, it'll be negative 3 times 2, which will give us negative 6, plus 1 will give us negative 5. So at point 3, it'll be negative 5. So right here. And then once you get those 3 dots down, you can just draw your line. So let's do that. All right, now we have our line. Now let's find the slope, right? So we already know what the slope is because we've been given it in the slope-intercept form equation. But let's find it as if we didn't have that. So the formula for slope is going to be rise over run. So you could pick any 2 points on the line, and all you have to do is figure out how much the y value changed and then how much the x value changed, and you're going to divide the y by the x. All right, so let's pick this point right here and then this point right here. So these 2 points. How much does the y value increase? So it goes from negative 9 to negative 5. So that means that it increased by 4, right? So it went up by 4. And then how much did it increase in the x direction? So it went from negative 5 to negative 3. So that's an increase of 2. So we went up 4 and we went right 2. So we're going to put rise, which is 4, over run, which is 2, and that'll give us a slope of 2, which is exactly what we had right here for m. All right, so now that we have that, let's move on to the x-intercept, y-intercept, and midpoint. All right, so we already have our y-intercept as was given in the equation, but what's our x-intercept? Similar to the y-intercept, the x-intercept is just the point at which the line goes through the x-axis. And if you have your line already drawn, it's pretty easy to point out. So it's going to be right here. But if you don't have it drawn out graphically, you could figure it out using the equation. So we have the equation y equals 2x plus 1. And if you want to find whenever y is equal to 0, y equal to 0 will be whenever it's crossing through the x-axis. So think about it. If y is 2, that means it's 2 above the x-axis. But if y is 0, that means it's crossing through the x-axis. So we're going to rewrite this equation except make y equal to 0. So it's going to be 0 is equal to 2x plus 1. We're going to subtract 1 from both sides. So we get negative 1 is equal to 2x divided by 2. Divide by 2, and we end up getting negative 1/2. So the x-intercept is going to be a negative 1/2, as is plotted right here. All right, so lastly, we're going to do the midpoint. Okay, so what is the midpoint of line segment AB? We're going to use our midpoint formula right here. As you can see, we're going to find the x value of the first point, the x value of the second point. We're going to add those two together, and we're going to divide by 2. And then we're going to do the same exact thing for the y values. All right. So the x value of A is going to be 0. And then the x value of B is going to be 4. And we're going to divide that by 2, put a comma. So then the y value of A is going to be 1, and then the y value of B is going to be 9. So 1 plus 9, divide that by 2. So that would end up giving us 4 divided by 2 is 2. 10 divided by 2 is 5. So 2 comma 5 will be our midpoint. So 2 comma 5, so that'll be right here. The midpoint formula is also handy in some other circumstances. So occasionally the ACT will ask a question like, what point is 1/3 of the way between A and B? So they're saying it's going to be 1/3 the distance of A to B. And the way we do that is we just remove this 2, because the reason why the 2 is there is because we're trying to see what's halfway between A and B. But now we're trying to see what's 1/3 of the way. So we're going to replace these 2's with 3's, and that'll give us what's 1/3 of the way. Same thing if they ask us what's 1/4 of the way. We replace the 3 with a 4, and onward. In this Blackboard lesson, we're going to talk about arithmetic sequences and geometric sequences. All right, so as you can see right here, arithmetic sequences have a common difference. And what that means is between each number, there's going to be a common difference between them. So for this set, we go from 1 to 3, from 3 to 5, from 5 to 7. So the difference between each one is 2, right? So you're adding 2 each time. So in arithmetic sequence, you could either add or subtract. They could be different because you added or different because you subtracted. If you think about it, we could go in the opposite direction. So we could go from 15 to 13 to 11 to 9, and they would still have a common difference of 2. So an arithmetic sequence is a sequence in which each number is either added to or subtracted by the same number. All right, now for a geometric sequence. So a geometric sequence has a common ratio. That means that each number is either multiplied by or divided by a particular number to get to the next number. So as you can see, we have 1, 3, 9, 27, 81, 243, and 792. So if you notice, if you multiply each number by 3, so if we did 1 times 3, we would get 3. 3 times 3, we would get 9. 9 times 3, we'd get 27. 27 times 3, we'd get 81, and onward. But it can also be division, right? So if you took 792 right here and you divided by 3, so divide by 3, you would get 243. And then if you divided 243 by 3, you would get 81, and onward. So an arithmetic sequence is going to be addition and subtraction, and a geometric sequence is going to be multiplication and division. If the first and third term of an arithmetic sequence is 1 and 9, what is the sixth term? All right, this is a very common question type. So the first and third is going to be 1 and 9. So let's write that out. So we have 1, comma, unknown right here, and then we have 9 is the third term, and we're looking for the sixth term. So let's just continue. So we have the fourth term right here, the fifth term right here, and the sixth term right here. And this is what we're looking for right here. All right, but to do so, we need to find out what the common difference is, because this is an arithmetic sequence. So we go from 1 to 9, and we have a gap in between. So there's going to have to be a number that if you added it to 1 twice, you would get 9. So there's a difference between 1 and 9 of 8. So the number that you would have to add 2 times to 1 would be 4, right? So if we did 1 plus 4, we would get 5. And then 5 plus 4 would give us 9. And then we're just going to have to continue this, right? So 9 plus 4 is going to give us 13. 13 plus 4 is going to give us 17. And then lastly, what our answer is going to be is 17 plus 4 is going to give us 21. So first thing you have to do in any of these problems is either find the common difference or the common ratio and just extend it outward. All right, so now for a geometric sequence. What is x in the following geometric sequence? 6, 18, x, 162, 486. So it's a geometric sequence, so we need to find the common ratio. So the easiest way to do that is if we just take 18 and divide by 6, it'll give us the ratio. So 18 divided by 6, that's going to give us 3. So that means that we know we have to multiply 6 by 3 to get 18. Let's see if that is correct for this one. So 162 times 3 will also give us 486. So we know that 3 is going to be the common ratio. So we're just going to do 18 times 3. So that's going to give us 54. So x is going to be equal to 54. Is the following sequence arithmetic or geometric? So 500, 380, 260, 140, 20, negative 100, negative 222. All right, so right off the bat, we see that it goes into the negatives, and it wouldn't do that if we were multiplying by the same number. If we were multiplying by the same number each time, it would bounce between negative and positive, negative and positive. So we know that it can't be geometric. But I'm going to show you how to check even if we didn't have this little negative portion right here. All right, so we go from 500 to 380, from 380 to 260, from 260 to 140. So the first thing you should do is just subtract each one from each other. So let's do 500 minus 380 right here. And then we're going to do 380 minus 260. So 380 minus 260. And then 260 minus 140. Minus 140. And all of those will give you the same number. It'll give you 120, 120, 120. So that means that we know that we have a common difference, right? But the way you would check for a common ratio is you do the same exact thing, except you would divide instead of subtract. So you would do 500 divided by 380. Then you do 380 divided by 260. 260 divided by 140. And onward. And all of these should have the exact same answer as their ratio, which means that it would have a common ratio. But this one does not. So we know that this is going to be an arithmetic sequence. Continue this geometric sequence. All right, so we already know it's a geometric sequence, so we know that it'll have a common ratio. So let's figure out what that ratio is. The way we can do that is we just divide the second number by the first number, and we get 5. So we know that each number is going to be multiplied by 5. Right, so we're just going to continue by multiplying each number by 5. So 5 times 5 is going to give us 25. And then 25 times 5 is going to give us 125. And we're just going to continue to do that onward. And that's how you get every sequential number. You would just multiply by 5, multiply by 5, multiply by 5. All right, now let's do it for an arithmetic sequence. So we need to find the common difference. All right, so what's the difference between 5 and 1? You do that by taking 5 and subtracting 1. So we know that there's a difference of 4. So we're going to be adding 4 in between each number in the sequence. So we're going to add 4 again, which is going to give us 9. Then we're going to add 4 again, which is going to give us 13. We're going to add 4 again, which is going to give us 17. And we would just do that on and on forever. In this Blackboard lesson, we're going to go over perimeter, area, and volume of circles, cylinders, rectangles, triangles, and trapezoids. All right, let's get straight into it. The good thing about perimeter, area, and volume is you're typically just going to take the information given and you're going to plug it into the equations, right? So that's why it's so essential that you memorize these equations. It'll make your life so much easier. A swimming pool with a radius of 5 meters and a height of 1 meter was filled with water. How much water was the pool holding in meters cubed? All right, so the formula for volume of a cylinder is pi r squared, which is also the formula for the area of a circle, and then you're going to multiply that by the height. And the reason why is because you're just finding the area of the base, which is circular, and then you're multiplying it times height. So we have a radius of 5 meters. So 5 squared, radius squared, is going to give us 25 times pi, and that will be our area of the base. But now we have to multiply that by the height, and the height is 1 meter. So we just multiply by 1, and we end up getting 25 pi again. So it's going to be 25 pi meters cubed. That'll be the answer. If a pie chart had a radius of 10 and each of the 4 segments took up exactly 25% of the chart, what is the area of each segment? All right, so let's identify which formula we're using. So we're looking for the area of a circle, so that's going to be right here. It's pi r squared. We've been given the radius, so we just plug that in. So it's going to be pi times 10 squared. So that's going to end up being 100 pi. And then it's saying each of the 4 segments took up exactly 25% of the chart. What is the area of each segment? So we can just multiply this by 0.25, or 25%, and that would give us 25 pi, and that would be our answer. When submerged, the rise in water level is exactly equivalent to the volume of the object. If a spherical object was submerged in a cylinder with a radius of 10 inches, and the water level rose by 2 inches, what is the radius of the spherical object? All right, so all we have to do is find the area of the cylinder that has a 10-inch radius and a 2-inch height, because that's how much the water was displaced. So in order to find the area of the circle at the base, we're just going to do 10 squared times pi, which is going to give us pi times 100, or 100 pi. And then we're just going to multiply that by 2, because you multiply the base times the height, and that'll give us 200 pi. If the base is equal to 10, the height is equal to 20, and the area is equal to 400, what is the perimeter of this trapezoid, assuming that it's a perfectly symmetrical trapezoid? All right, let's take a look. So we have a base of 10, a height of 20, and then an area of 400. All right, so the way we're going to do this is we first have to figure out what that length is, and we're going to do that using the formula for area of a trapezoid, since we already have the area. So 400 is going to be equal to A plus B, so 10 plus X, divided by 2 times the height, which is 20. All right, from this point on, we just need to do some algebra, get x by itself, and solve. All right, so we're going to divide both sides by 20 to get rid of that 20. And then we're going to multiply both sides by 2 to get rid of that. So bam, bam, let's do that in one step. So we get 40 is equal to 10 plus x. Subtract 10 from both sides. And we get x is equal to 30. So we now know that this side length is going to be 30. All right, so we have both side lengths, but now we need to find these lengths right here. And we know that they're going to be equivalent because it's a perfectly symmetrical trapezoid. And the way we're going to do this is we are going to use Pythagorean theorem. We're going to separate these into 2 right triangles and solve. Okay, so if the length of this is 30 and the length of this is 10, we know that there's going to be an overhang of 10 and 10 on each side because this has to be 10. Because they're parallel. All right, so I know this isn't drawn to scale. It's drawn horribly not to scale, but we're going to go with it. All right, and then we know the height is 20. So these sides are both going to be 20. So we're just going to use Pythagorean theorem. A squared plus b squared is c squared. So 20 squared plus 10 squared is going to be equal to the hypotenuse squared, or c squared. So 20 squared is going to be 400. 10 squared is going to be 100. We're going to add those together, and that'll give us 500 is equal to h squared. So let's take the square root of 500, and we get 22.4. So the hypotenuse is going to be equal to 22.4. All right, so now let's erase our x's and put that there. 22.4, 22.4. All right, so now we can just count the perimeter. We have 10, 10, 10, so that's going to be 30, plus another 10 is going to be 40, plus 22 plus 22. So that's going to end up giving us 85.2. In this Blackboard lesson, we're going to go over SOHCAHTOA, Pythagorean theorem, and some triangle rules. So all 3 of these are super essential for the ACT. You'll probably get 3 or 4 questions on each ACT involving triangles in some way or another. All right, so SOHCAHTOA, S-O-H-C-A-H-T-O-A. It stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Then Pythagorean theorem is a squared plus b squared equals c squared. And both of these formulas, well, SOHCAHTOA is more of an acronym than a formula, but they're super essential for the ACT. Make sure you have these memorized before you go into the test. All right, let's do a few problems. What would be the trigonometric equations for the triangle below? So we're going to do all of them, right? So sine, cosine, and tangent, all for angle y, right? So sine of y, let's figure out what that would be. So remember SOHCAHTOA, S-O-H-C-A-H-T-O-A. So sine is going to be opposite over hypotenuse. So the angle that is opposite of y is going to be g. So sine y is going to be equal to g over hypotenuse, and the hypotenuse is m. So sine y is g over m. All right, on to the next one. So now we're going to do cosine. So cosine of y is going to be equal to adjacent over hypotenuse. So the adjacent is right here, and the hypotenuse is up here. So cosine y is going to be L over m. L over m. All right. So lastly, for tangent. Tangent is going to be opposite over adjacent. So tan y is going to be equal to opposite, which is right here, over adjacent. So g over L. G over L. So we have all our trigonometric equations filled out. And in a real question, if you were given values for any of these, you would just plug the values in wherever you have those particular letters. So if instead of a G, we had a 5, you would just plug in 5 where all the G's are. And if instead of L, we had a 4, you would do the same exact thing. You would just plug that in instead of the L's. And you would get all the correct answers for the angles. So on to the next one. All right, for this one, we're going to have 2 different questions. What is the length of x? And we're going to use trig for that. And then what is the length of the hypotenuse? We're going to switch and use Pythagorean theorem for that one. All right, so we have an angle of 40 we have a side length of 12 and a side length of x, right? So this one is going to be the opposite, this one is going to be the adjacent, right? And if we have opposite and adjacent, we're going to have to use tangent. So remember, TOA, tangent is opposite over adjacent. So that means tan of 40 is going to equal opposite, so 12, over adjacent, which is x. So now we're just going to have to solve for x. So multiply both sides by x, and then we're going to have to divide both sides by tangent to get x by itself. So tan 40 divided by tan 40. So that's going to give us x is equal to 12 divided by tan 40, which is going to end up giving us 14.3. So we know that x is going to equal 14.3. All right, so now that we have that, we can use Pythagorean theorem to find the hypotenuse. All right, so a squared plus b squared is equal to c squared. We have a, so a is going to be 12. 12 squared is 144. And we're going to add that to 14.3 squared, which is going to give us 204. We're going to add those two together, and we're going to get 348.5. And you can do some fancy stuff to reduce that, but we're just going to plug that into the calculator and see what we get. All right, so we get 18.66. That would be the length of the hypotenuse, so 18.66. What is the measure of angle x in the parallelogram? All right, so we have angle x right here, we have an angle of 50 right here, and then an angle of 32 right here. All right, so one way you could do this, if this is a parallelogram, we could draw it out like this, right? So make it where these are all just parallel lines that are crossing each other. So this one's going to go back to our angle rules that we did earlier, right? So if this is 50, this is going to be 50. And if that's 50, this is going to be 50. And then if this is 50, this is alternate interior, so that'll be 50. Then that'll be 50. Then we come all the way over here, and then this will be 50, this will be 50, and this will be 50. So we have all of our 50s laid out. And now that we know all these, we'll be able to solve, right? So if we have a 32 right here and a 50 right here, and we know that every single triangle has 180 degrees total, we're just going to subtract those by 180. So 50 and 32 is going to be 82, and we're going to subtract that from 180, which is going to give us 98. So the angle of x will be 98 degrees. In this Blackboard lesson, we're going to talk about angle equivalencies. All right, so as you can see, we have a set of angles right here, and we have two parallel lines. So which angles are going to be equivalent to this angle right here? So the opposite angles are always going to be equivalent. So this will be equivalent. Let's put a star here. Then we have our alternate interior. So those are going to be right here. And then we have our opposite again. So we have another star. So all of these will be equivalent. Now let's do it for the other one. Let's do it for x. So we have this angle right here. The opposite one will be equivalent. And then the alternate interior will be equivalent. And then the opposite will be equivalent. So literally that's all it is, right? So if you look at these two, because these lines are parallel, this right here and this right here are exactly identical. So in the top left-hand corner, we have x. In the top right-hand corner, we have a y. In the bottom left-hand corner, we have y. In the bottom right-hand corner, we have x. That's why you have all those angle rules. It's really because these two, as long as the lines are parallel, are pretty much identical, right? And because of that, there's a bunch of cool things that we could do. And the ACT is going to ask a lot of questions to see how you could mathematically reason and toss these different angle rules around. So let's do a couple problems right now. All right, let's take a look at this. Let's try to figure out how many angles we could find without using any math. All right, so we have our 60 right here. So we know that the opposite angle right here is also going to be a 60. We have a y right here, and we know its alternate interior is going to be equivalent, and its alternate interior will be right here. So we got a y right there. We have a 40 right here, and its alternate interior will be right here. So we know that's 40. And then we have an x right here, and its alternate interior would be right here. So that's everything we can get right off the bat. But now, using our knowledge of lines and angles, we'll be able to go a little bit further, right? So we know that every line has a 180 degrees, right? It has 180 degrees. So if we have 40 degrees right here, and we know that the rest of this angle is going to make up 180, we could do 180 minus 40, and that'll give us that angle measure. So this angle measure will be 140 degrees. And if that angle is 140, we know that this angle is going to be 140. What about x and y? So we know that x plus y is going to have to equal 180 because they lie together on a line. All right, so we got all this information. Now if I said, what is x in terms of y? Right, so you want to write x in terms of y. All you would do is you would get x by itself by subtracting y from both sides. So you would get x is equal to 180 minus y. Now, what is the equation of angle y in this parallelogram in terms of x? All right, so we just did a similar problem, but let's look at it. So these are going to be parallel lines, and these are also going to be parallel lines. So what I like to do with parallel lines in parallelograms, I like to extend them out, right? Because then it makes it obvious that we could use our angle rules, right? So now this right here looks just like this. So we know that if y is right here, y is also going to be right here. And then y is also going to be right there, and it's going to be right there. And then if x is right here, we know x is going to be right here, x is going to be right here, and x is going to be right here. So now it's asking you to write y in terms of x. So since they lie on the same line, we know that y plus x is going to be equal to 180 degrees. So if we want to get y by itself, we subtract x, and we get y is equal to 180 degrees minus x. This Blackboard lesson is going to be on mean, median, and mode. All right, so first, mean. Mean is the average. So in order to find the average, you add all the numbers together and you divide by the total number of numbers that you added together. So say we had this sequence, 2, 5, and 3. We would add all of those together, so we'd add them together, and then we divide by the total number of numbers that we add together. And since there's 3 numbers in the sequence, we divide by 3. So we get 2 plus 5 plus 3, which would give us 10, and 10 divided by 3 will give us some decimal number, but we'll just keep it 10 divided by 3. So this would be the average of that set, or the mean of that set. All right, so now for the same set, so 2, 5, and 3, 5, and 3, the median, so the median is the middle number whenever you line them up in number order, right? So this is not number order, so we'd have to line them up by 2, 3, and then 5, and we'd select the middle number, which would be 3. All right, but what if there's 2 numbers in the middle? So say instead of this sequence, we had the same sequence, but we added one more number. So 2, 3, 5, 7. So what we do in this scenario is we'd take the 2 middle numbers, and we'd find the number right in the middle of them. And the way you do that is by finding the average of the 2 numbers. Whenever you average only 2 numbers, you're going to find the number that's right in the middle. So we do 3 plus 5 divided by 2. So that would be 8 divided by 2, or 4. And that makes sense because 4 is right in the middle of 3 and 5. So that would be the median in this scenario. 4 would be the median. So anytime you have 2 numbers in the middle, you're going to select the number in the middle of the 2 numbers, and you're going to do that by finding the average. And lastly, we have the mode. So the mode is the easiest one. You just look at the sequence of numbers and you pick the number that occurred the most amount of times, right? And mode and most sound similar. So say we had 1, 3, 5, 1. So 1 is the only number in here that occurred more than once. So that would be the mode. But then say that it continued and we had a 3, a 5, and then another 3. So now we have 2 5s, 2 1s, and 3 3s. So 3 would then be the mode. All right, let's do some practice problems. The 8 fish were measured and their lengths were recorded as 8, 3, 12, 14, 19, 25, 14, and 9. All right, so you know I didn't catch those fish because that's way too small. So first we're going to find the mean, and then we're going to go to the median and then the mode. So in order to find the mean, we're going to add all these numbers up together. So 8 plus 3 plus 12 plus 14 plus 19 plus 25 plus 14 plus 9, that'll give us 104, right? So 104. And then we're going to divide that by the total number of numbers. And it says there's 8 fish, so we're going to divide that by 8. And that'll end up giving us 13. So the mean, or the average, is 13. So now for the median, we're going to have to line these numbers up in order, right? And I find the best way to do this is line them up right on side of the numbers that you've already been given to make sure you don't miss any, right? So we got 3 right here, scratch out the 3. And then we got 8, scratch out the 8, 9, 12, 14, 14, so 2 14s. And then we got 19, and then 25. But you see how we lined them up next to each number? That way you make sure you don't miss any, because if you're missing a space, you know you missed one. All right, so now we're going to select the middle number. And the way we could do that is we could cross out from outside to inside. So make sure you remember which side you started on. So you start on left, so you're going to finish on the right. Cross out, cross out, cross out, cross out. All right, we finished on the right, and we have 2 numbers in the middle. So we're going to have to find the number right in the middle of those 2 numbers. And it's obvious that that number is 13 because it's 12 and 14. But the way you would find that if they weren't obvious is you would add the 2 together. So you'd do 12 plus 14, 12 plus 14, and you would divide by 2, which is finding the average of the 2 numbers. And whenever you average 2 numbers, it gives you the number that's smack dab in the middle of the 2. So if you did that, that would give you 13. So the median would also be 13. And then the mode, let's check this one out. So the mode is the number that occurs the most times in the sequence. So the only number that occurs more than once is 14. So 14 is going to be our mode, right? And this is a challenge question. So say we were given the exact same list, but the question asked, the current mean is 13. What length of fish would we have to add to the list in order to make the mean go from 13 to 14? All right, so we want the mean to go from 13 to 14, and we can only add 1 more fish. So we're going to go from 8 fish to 9 fish, and we're going to add a fish of length x, right? So we know that all these added together equal 104. So for the new mean, it would be 104 plus x divided by our new number, so 9, will equal 14. That's what they want the new mean to be. So now we just solve for x. So we multiply by 9 on both sides. So we end up getting 104 plus x is equal to 126. We subtract 104 on both sides, and we get x is equal to 22, which means we'd have to add a 22-inch fish to this list in order to make the mean 14. In this Blackboard lesson, we're going to go over percentages. So what is a percentage? Let's look at the word itself. So percent. Per meaning divide, and cent meaning 100. So percent literally means to divide by 100. So if I said, what percent is 1 of 4? Let's write that out. So what percent is 1 of 4? We'd do 1 over 4, and we'd see if we put that over 100, what would the top number be? So what would this number be? This number will be your percent, right? And that's why this equation looks like it does, because if we wanted to solve for x, we'd multiply both sides by 100, and we'd end up getting percentage is equal to part divided by whole times 100, which is exactly what we have right here. So that's what percentage is. Let's work out a few problems, and all we're going to have to do is take from the problems and plug directly into this equation. A poll of 4,000 voters was taken before the local election in New Orleans. The result of the poll are given below. What percentage of voters voted for Alvarez? All right, so as you can see, Alvarez got 1,550 votes. And there was 4,000 votes total. And since percentage is going to be part divided by whole, we know that this is going to be the whole, right? So 4,000 is going to be on the bottom, and then this is going to be the part right here. So that's going to be on the top, 1,550. And then we're going to multiply that by 100%. So by 100%. And that'll end up giving us, let's see. So that ends up giving us 38.75, or we could round up to 39%. Shaq made 53% of the free throws that he shot. Shaq shot 10,000 free throws in his career. How many did he make? All right, so we've been given the percentage, and we know the percentage is going to go right here on the left. And then we've been given the whole, so he shot 10,000 total, so we know that's going to be the whole, so that's going to go right here. And we already have the percentage, because that's always there. So what we're looking for is the part, and we're going to list that as x in our equation. So let's just write it out. 53% is equal to x divided by 10,000 times 100%. All right, so one way I like to do this, in every single equation, this percentage is going to cancel out with this and make this a decimal. So you're just going to move the decimal over twice to the left and put it right there. So now we have 0.53 is equal to x divided by 10,000. Right? So multiply both sides by 10,000. And we end up getting 10,000 times 0.53 is equal to x. So that would be x is equal to 5,300. So that's the total amount of free throws that Shaq made, because that's the part that we just found. The worker made $10 an hour and received a 10% raise. How much does he now make per hour? All right, so we've been given the percentage. He's made a 10% raise, so we're going to put that on this side. We know that he originally made $10 an hour, so that's going to be the whole, and we're looking for the part, which is going to be how much his wage increased. And all that is going to be times 100%. So again, we could cancel out that 100%, cancel out that percentage, and just move the decimal twice to the left. So now we have 0.10 is equal to x over 10. So multiply both sides by 10 to get rid of that. So multiply by 10, and we end up getting 1 is equal to x. So we know that his raise of 10% was $1, right? So we're going to add that on to the original $10. So it's going to be 10 plus 1, and that's going to give us 11. So his new hourly wage is going to be $11 per hour. The main flagpole at the convention center is 90 foot tall. A second flagpole is 65 foot tall. The length of the larger flagpole is what percentage of the length of the shorter flagpole. So anytime you see percent of, the thing that follows, that's actually going to be the whole. So even though that one's smaller, it's going to be the whole. So the length of the shorter flagpole is 65 foot. So 65 foot is going to go at the bottom, and then 90 foot is going to go at the top. So 90 divided by 65 times 100% is going to give us our answer. So if you do that and then you round up, that's going to end up giving us 138%. So 90 divided by 65 is going to give you 1.38, and then you're going to multiply that by 100%. Blackboard lesson is going to be on probability. So what is probability? Probability is the chance that something will occur, right? So as you can see, the equation is probability is desired outcomes divided by possible outcomes. All right, and we're going to go over a couple problems that are going to reveal that to you. Jenna has 125 red marbles, 50 blue marbles, and 81 yellow marbles. If one were to randomly select from her collection, what is the probability that they would select a red marble? All right, so we're looking for desired outcomes over possible outcomes. So the desired outcome is selecting a red marble, and there's 125 opportunities to do that. So the top number is going to be 125, and then the bottom number is going to be the adding of all of these marbles together. So we're going to add 125, 50, and 81. Make sure you always include even the marbles that you want to select, right? So we're going to add those together, and we're going to get 256. So our probability of selecting a marble, a red marble, would be 125 over 256. And on the ACT, whatever answer you get, make sure it's in its reduced form. So we would take the time to reduce this, but we'll skip that for now. There are 4 possible answer choices for each question on a multiple point quiz. If the student guesses at random, what would be the probability of them getting all 5 questions correct? All right, so the desired outcome would be them getting the correct answer. So that would be 1 opportunity out of the 4. And the possible outcomes is the 4 answer choices. So they have a 1 out of 4 chance of getting any given question correct, right? But we're asking, what's the probability of them getting all 5 questions correct? So that would be and, right? So that would fall under this umbrella, right? Because it would be event A and B and C and D and E, getting 1 through 5 all correct. So as it shows right here, we're going to multiply all these together. So there's a 1 out of 4 chance of getting the first one correct. There's a 1 out of 4 getting the second one, a 1 out of 4 of the third one, a 1 out of 4 of the fourth one, and then a 1 out of 4 of the fifth one. So we're just going to multiply all those together. So 1 times 1 times 1 times 1 is going to give us 1. And then 4 times 4 times 4 times 4 times 4, that's going to give us 1,024. So our chance of getting all 5 correct, if we guessed randomly, will be 1 out of 1,024. There are 24 students with A's, 30 with B's, and 15 with C's. What is the probability of randomly selecting a student with a B or a C? All right, so as you can see, we're doing an OR problem. So whenever you have an OR problem, it shows right here that you're going to add each probability together. So we're going to find the probability of event B and then the probability of event C, and we're just going to add the two together. So there's 30 students with B's, and how many students are there total? So 24 plus 30, it's going to give us 54, plus 15, that's going to give us 69, right? So it's going to be 30 over 69, and then we're going to add that to C. There's 15 people with C's, so it'll be 15 over 69 again. So we're going to add those two together, and we're going to get 45 over 69. So that'll be our probability of selecting somebody with either a B or a C. And think about the or real quick. So if I said, what's the probability of landing on heads or tails whenever you flip a coin? So it's a 50% chance of landing on heads, and then you have a 50% chance of landing on tails. And you're going to add those together because you have a 100% chance of landing on either heads or tails. So anytime you see either or, you know you're going to be adding the two probabilities together. A sandwich company has 4 breads, 3 sauces, and 8 meats. How many unique sandwiches could you make with these ingredients? All right, so this isn't a probability question, but you could look at it like a probability question. So if I said there's one particular bread that I want you to select, right? So say you were selecting at random and I wanted you to select sourdough, right? And then there's 3 sauces and I wanted you to select Chick-fil-A sauce. And then there was 8 meats and I wanted you to select chicken. All right, so what would be your probability of randomly selecting all 3 of those? So you'd have a 1 out of 4 chance of selecting sourdough. You'd have a 1 out of 3 chance of selecting Chick-fil-A sauce. And you'd have 1 out of 3 chance of selecting chicken. Well, 1 out of 8, my bad. So your chance of selecting all those together, since it's an and situation, it would fall under this umbrella, you'd multiply all of them together. So you would end up having a 1 out of 96 chance of randomly selecting all those. And the reason why it would be 1 out of 96 is because you can make 96 total combinations with these 3 ingredients, right? So there's 96 total unique sandwiches that you could make. And if you wanted to select just one of those, you would have a 1 out of 96 chance of getting that particular sandwich. In this Blackboard lesson, we're going to talk about ratios and proportions. So a ratio compares 2 quantities by dividing one into the other. And a proportion is just 2 ratios with an equal sign in between them, right? So a proportion is 2 equivalent ratios. All right, so let's work out some problems. A recipe requires 6 eggs to every 2 cups of sugar. How many eggs would we need for 12 cups of sugar? All right, so we've been given a ratio right here. And in order to solve this, we're going to have to make it a proportion with a variable. All right, so we have 6 eggs to every 2 cups of sugar. It doesn't matter which order you put the first one in, but you just have to make sure that the second one is in the same order. So we're going to have eggs on top, sugar on bottom. So we know that we have 12 cups of sugar, so it's going to go on the bottom, 12S. And we don't know how many eggs, so let's just put X eggs. Then we just solve for X, right? So we could just multiply 12 by both sides to get rid of that. Multiply by 12. So this is going to be 6 divided by 2, which is going to give us 3, times 12 is going to give us 36. So it's going to be 36 is equal to X. So the amount of eggs we need is 36 eggs. Now let's look at the proportions. So 6 divided by 2 is going to be equal to 36 divided by 12. And this is true. So if you do 6 divided by 2, you get 3. And if you do 36 divided by 12, you're going to get 3 because they're equal to each other. So that's the key about proportions. Whatever your answer is going to be, make sure it is equal to the original proportion whenever you divide it in the calculator. A map states that 1/4 inch represents 20 miles. How many miles apart are 2 towns separated by 5 inches on this map? All right, so 1/4 inch represents 20 miles can be represented as a ratio, right? So 1/4 inch to every 20 miles, right? So now we're going to make that equivalent to another ratio. We've been given 5 inches, so we're going to put that at the top. So 5 inches over X miles, right? So we're going to cross multiply to solve for X. So we're going to cross multiply. So we get 1/4X is equal to 20 times 5. That's going to give us 100. So now we just get rid of 1/4 and we divide by 1/4 to do that. Whenever you divide by a fraction, you flip the sign and multiply. So we're going to do times 4 over 1. And we get X is equal to 400 miles. So we know that these 2 towns are 400 miles apart. Now let's check it. So 1/4 divided by 20 is equivalent to 5 divided by 400. All right. So if you put both of these in your calculator, you would get 80. And that's how you know they're correct, because it'll end up being 80 is equal to 80. What are the side lengths of the smaller triangle? All right, so anytime you have a triangle that's segmented by a line and there's a right angle, you're going to know that these two triangles are similar triangles, which means that their ratios are the same. Right, so we could set this up with this as a ratio, and then this up with the unknown side length right there as another ratio, and put them equal to each other as a proportion. All right, so we could either do 12 divided by 4 or 4 divided by 12. So let's just do 4 divided by 12. And then on this side, we just have to make sure that the bigger side is on the bottom. So 6 is on bottom over x. And then we just solve for x. So we multiply both sides by 6. And we end up getting 6 times 4 is going to give us 24. Divided by 12 is going to give us 2. So we get x is equal to 2. So that means that this side length is going to be equal to 2. And that makes sense. So let's draw it out again. So we got 4 divided by 12 is equal to 2 divided by 6. And if you do both of these, you could simplify them to 1 over 3, 1 over 3. The ratio of A to B is 6 to 2, and B to C is 1 to 2. What is the ratio of A to B? All right. So the way we're going to do this is we're going to make the b's in both of the ratios equivalent by multiplying by some factor. And then once we do that, we can just smash the rest of it together. And I'll show you all why in a second. All right, so b is 2 in this one, and then b is 1 in this one. So if we multiply this whole side by 2, right? So then we'd have 2 to 4 and 6 to 2. So the b's would be the same. So we could just scratch out the b's and combine the 6 and 4. So the ratio of A to C would be 6 to 4, or in reduced form would be 3 to 2. But why is that? All right, let's draw it out graphically. I guess this wouldn't be graphically, it would just be a representation. Right, so 6 to 2. We're going to draw little blocks, right? So 6 to 2. All right. Now this one, B to C, is 1 to 2, right? So 1 to 2. So this is going to be B, this is going to be C, this is A, this is B. Now say we multiply this whole side by 2. It now makes it where B is equal to 2, and then C is equal to 4. So since B is equal to the same thing, and B is what we're using to compare the two, we know that these two are at the same level, right? So they're at the same factor. We can just smash them together. So we just scratch out the b's, since they're equivalent, and mash the A and the C together. And it'll show us that A, we have 6, C, we have 4. We reduce that into 3 and 2. All right. If you're still here, that means that you have the grit and determination to watch an hour-and-a-half long video on mathematics. So keep working hard, keep grinding, and I promise you'll see results. Thank you very much for watching. Good night and good luck.